At this point now, we can start actually building our predictive models. It's organized all of that data, and we're going to just put it in a folder here to save our various predictive model files. So this is where it starts using our predictive modeling software, Cognalysis Multirate. In a minute or so, you'll start to see that each one of these various panels will start to get some information showing up on them. And so each one of these represents a different predictive model. This first one is for the closure probability within the particular time step. So this is within a particular year. What's the probability that a claim will close within that year? What's the probability that it changes in value, but from the beginning of that time, from the beginning of that year to the end of that year? What's the probability that it, or given that it does change in value, what is the new value as a function of the original value? And any of the, all of these are a function of whatever characteristics are being used here. Notice you've got a lot of them that are included. And part of, obviously, any predictive modeling exercise is to try to simplify that model as much as possible. And so it's going to go through and do some of that on its own, and then you can go in and actually try to make additional improvements to models using the software, using the predictive modeling software. This model is the payment probability, so the probability that there's a payment within that particular time step. And then the partial payment is if there is a payment and it's not closed as well, what is the amount of payment? Notice that only these models are being built. It's because the other models here for lag, frequency, and severity are all emergence models. So right now we're just talking about claim development. We are using exposure characteristics in looking at that claim development. But at this point we're only looking at development on case reserves that are already open. This is an iterative process. This predictive modeling process is what we call iterative marginal technique, where we're looking at each variable on the margin to all the other ones. And so in that way it's iterative. The first go through is actually building these models with every variable included. You might be able to make out that there's some gray fields. They're pretty close to the end here actually. These are actually random characteristics that are being added to each predictive model as a test, essentially, on the predictive power of the other variables. And so that then in the second go around, we'll actually trim out all of those variables. So I'm going to actually take it past this. I'm going to close this down and show you one where this process has already been completed. All right, and we've done two things here. We've actually refined those models. You notice that we've got some names here: close prob 2, change prob 2, new value 1. That's actually saying that we've actually selected a different model. You've got an option to select a different model. I'm going to actually open this up to show you what one of these models looks like in Multirate. Okay, so this is our Multirate screen, and we've got a number of variables that are found to be predictive for the probability of a claim closing within the next year. The most predictive variable was actually found to be the transaction date, so the calendar period. We're actually seeing that there is a strong relationship here. The blue dots here are showing the raw relationship over time. So what this is saying is there does appear to be a change in terms of closure rate by calendar period. The orange dots are actually adjusting for all of the variables, and the black line is our modeled relationship. And so actually after adjusting for other variables, we're even seeing more of a relationship here on transaction date. So that gets at the whole predictive modeling aspect of this. We've also got a relationship with regard to beginning case reserve. The larger claims are not closing as fast. That's not terribly surprising here, but something that's taken into account in the model. And this is looking at one of these exposure fields. All right, so this is exposure field 10. And it's showing some significant differences here in terms of closure rate for different values of that field. So you can see in some cases closing considerably slower than the average or faster than the average. We're only showing the top 20 here, but you can actually look at the full table of all the different factors that are being developed. Now this is on the margin to all other variables. We're doing that same thing for each one of these models, And again, the user can go into the predictive modeling software, make adjustments. Maybe they want to make a particular relationship linear. Maybe they want to add some smoothing techniques. Things like zip code. If you've got zip code, hugely valuable. I don't have zip code shown here, but I can just tell you that it's very, very powerful, in particular with some of the smoothing techniques that we use, and it can tell you a lot about claim development and emergence. The next thing that we've done is actually to take that information and click this button here for Simulate Development. And what that's doing is then simulating from the current case reserve inventory, going forward one time step at a time, but over however many paths you select. So in this case, I've selected 1,000 paths to generate projections, and we're going to go over to visualize the results here. This is showing for each open claim in the inventory a dot, a blue dot. We're showing this log scale. The bottom axis is the beginning case reserve, so the current case reserve on that claim. And this is the average of future payments from our simulated path. Now, actually, before I jump to that, I actually want to show you where the data actually resides. It actually gets written out to a table in SQL. And so, in this case, we're only looking at the top 1,000 rows. But we've got path, we've got claim ID, we've got a time step, beginning case reserve, ending case reserve, and a payment. And so this is going to be millions of records on this particular table. Obviously, you need some way to be able to see that, some way to understand really what's going on here in your analysis. This, as I said, is individual case reserves. And everyone, I don't know if you can see this when I'm hovering over a number or a dot, you can see specific information about that claim. You can see the claim ID and each of the values that it has for all of the fields that were included in any of the analyses. And we can filter this any way we want, but let's take a look at one of these fields maybe. Let's take a look at one here. This particular one that I'm highlighting currently has a case reserve of about $5 million, and we're projecting future payments of $4 million. So we're showing slight case savings. If we had perfect case reserves, where they were a perfect predictor of future payments, we would see things along a straight line along the diagonal. And you're obviously never going to see that. But you do see some other things. For example, this particular set of data has a whole bunch of claims valued at $100 currently. But they range anywhere from, in this case, 1.7 million estimated for future payments down to actually below $100. And that's all a function of the various characteristics of those particular claims. If I click again maybe on that particular case reserve we're looking at before, and then go to another one of these graphs, we can actually see the output from that particular claim. All right, so this particular claim, this dashed line is the current case reserve, and the red line here is the average of future payments. Each vertical blue slice here is a path. And so we're actually saying that there's about a maybe 8% chance that nothing will pay at all on this claim. We're saying there's a very strong chance that it will pay as limit. That's basically what you're hitting here is the limit, and we've got an average here. And this will look different, obviously, claim by claim that you have. We also then can look at this for any aggregation you might be interested in. And we can see it, for example, what it looks like in total. And so in this case, we've got case reserves of about 118 million, average future payments of about 266 million, distributed like this. And so you start to see where the value can come in for things like enterprise risk management, looking at reinsurance, all sorts of things. One of the things that you can see after even just doing the development simulation, before even moving on to emergence, is to see for that development what were found to be the most important characteristics to get you from the current case reserve to that average of future payments that are being projected. And I'm going to double click on this to open up that analysis. This explanatory model is telling us, first of all, that things like the beginning case reserve is very important. And that's not surprising. A small case reserve has potential to get big, and one that's sitting at the limit does not. It actually is going to see a downward. So you're almost always going to see this sort of relationship. And that's something really that kind of sets this apart from looking at traditional triangle analysis, for example, in that it matters where those case reserves are sitting relative to their limits. And if we look at some of these other fields, we're seeing that exposure field 11 is found to be a very predictive field with a factor of 1.7 to the overall relationship to the overall average. So in other words, saying that claims with a value of A for that particular characteristic will end up developing on average, we believe, 70% more than the typical claim, and the ones valued C will be 46%. Now you can see most things are in one of those two categories, so it's kind of a either or sort of thing, a few in the null category. We also have claim field 7 coming up as an important one, and here we show the impact of null sometimes. Sometimes null can be very predictive. There's a much smaller potential for upward development if that is actually null value for this particular field. And we've got another one here where the value is U for claim field 7, where it's much more significant upward development. So let's close this down. Let's take a look at that actually. Let's take a look at this scatter plot, and let's take a look at that particular claim field 7. I'm going to look at the null valued claims for that particular field, and you'll notice that you can see right in here that we're projecting that those are going to develop considerably lower than the average. And alternatively, if I change that to a value of U there, you can see that there's considerable development being shown on those particular claims. Now, some of them that are sitting up high and close to the limits are still showing slight case savings. But overall, we're talking about a lot of development. You can also see that if you go to the payment distribution. This is, again, for the claim field 7 equals U category, that we're seeing a lot of upward development there. If I change that to null, we can see considerably less upward development. I just want to show, while I'm showing some of these graphs, there are options here. Let's say we want to select a number of these, and you can select different combinations of things. So here's for a number of different selections for that claim field 7. What we're saying, a relatively small case reserve amount blowing up to something quite large. We can export that information. So let's do an export. Let's do a print actually first. We'll print that out. Just print an Adobe file. And it's showing you that same sort of information, telling you exactly what was in that filter. All of this data is stored in the SQL environment. You can always get it out by querying the SQL environment. We're trying to give you as many ways as possible to try to see it and to try to use that information directly from the software. We can also do an export of that data. This is just showing you the selection that you had, and this is the total. And so you can see kind of path by path how they actually compare to each other.